Welcome to Physics Lab 4 on Spring Mass Systems. Purpose. The purpose of this lab was to examine, analyze, and model the motion of an oscillating spring that moves in an arc-like motion from a video utilizing data code and physics principles. At the conclusion of this lab, a sufficient computational model of the spring mass system was obtained. So fundamental principles used in this lab were Newton's second law and the energy principle. Some of the equations below used were the final velocity update equation, position update equation, kinetic energy, potential energy due to gravity, potential energy due to spring, the change in energy of the system, and the spring force. Here are my initial conditions. You can see the mass of the ball, the initial position of the ball, the initial velocity. You can see the relaxed length of the spring and the system, which included the ball, spring, and the earth, and the surroundings, which included nothing because we're working with a multi-particle system. Here's the code used for the spring mass system plot. You can see my initial conditions at the left there, the top left of the first picture. You can see my ball dot position signifying my position of the ball, and then the velocity, the initial velocity as well. And then you can go down and see you can see the gravity constant, spring constant, and the relaxed length of the spring. And looking in the middle, you see the L, which is L, which is the length of the spring, which is the position of the ball minus the attachment point, which is spring dot pause, and then L hat, which we take the vector L and divide it by the magnitude of L to get the unit vector. And then we have the current length, which is equal to S, which is the magnitude of L minus L naught. And below that, you can see my equations for kinetic energy, gravitational potential energy, and spring potential energy, and the total energy, which is the kinetic plus the spring potential energy plus the gravitational potential energy. At the bottom, you can also see the spring force equation, the net force equation, which is gravity plus spring, and you can also see the velocity update and position update formulas. Here's my data from Excel Tracker. You can see from my Excel graph that the graph does oscillate, and that's what a spring graph is supposed to look like. My exposition data is not actually, the numbers aren't exactly correct, but it does, because this is only the X position and the Y position. I don't have the time for each uh, portion of the graph. Um, but you can see that it oscillates like a spring is supposed to oscillate. And you can look to the right and see my tracker data, which I do have both of the graphs for the X position and the Y position, and you can see how it oscillates according to the time. Here's my computational model. Um, you can see that my computational model, which is the blue line, is correct, but the experimental uh, curve or model is not right. It's supposed to match the blue curve, but I can never figure out why this didn't match. I don't know what the issue could have been. Maybe it was something with data, which I tried to fix, or my code, but I think my code was also correct, so I don't know why that didn't work. Um, but moving on, what does it mean? According to my graph, the energy principle is satisfied because the change in energy of the system is equal to zero. And I know that this is true because when we have a multi-particle system and nothing's in the surroundings, no work can be done. So delta E system is supposed to be equal to zero. And when you look at my graph here, you can see that delta E, the orange line, is approximately zero for the entire period of oscillations. And I was able to conclude that the exposition's period of oscillation was around 1.429 seconds, and that the Y position period of oscillation was around 1.62 seconds. I think that maybe the Y position period of oscillation was a bit longer. It's because that the spring was mostly moving in the Y direction, to be honest. Because when we got the data from the tracker video, we could see that the X position really wasn't moving too much. It was kind of standing between 0.9 and like 1, whereas the Y position had a wider range of movement. So yeah, thanks for watching and have a good day.